Hi friends, hi everyone, thank you very much for joining. Again, we talk about Spring Start here and we talk about chapter 10, which is a very important chapter. I will actually go a little bit deeper than what I have here in the book today. I'm still using the book as this is a playlist made particularly for going through the book. But what we're going to talk is a little bit more, and I promise you that if I will go with a second edition, and hopefully I will do somewhere in the near future, I'm gonna enhance a bit, I'm gonna augment a bit this chapter because there is a little bit more than I want to be in here. I was rereading shortly this chapter just before starting now the live stream to remember how was it designed at the very beginning, and I have realized that I have things to enhance here. Of course, I do consider also all the reviews I got throughout this. I think it's already like 4 years and something since the book has been published. I think it was 2020 when we published the book, or 2021. So 4 or 5 years soon. This is chapter 10. Let's go with the very beginning. It's about implementing REST services. What I say I want to enhance is basically the fact that in this chapter I'm going very technically about how Spring works behind the scenes, but I do feel that for someone at the beginning, best practices should have been also discussed a little bit better. So that's what I want to enhance now regarding this. By the way, if you are here with me live, remember you have the chat. You can always write me in the live chat or start discussions or say hello, of course. And we will talk, and I will try to answer your questions if you have, or attend to the talk if that's needed, if my intervention is needed. If not, and if you are not here live with me, you always have the comments section, this definitely, and you can find me on social media. You already know that. You can find me on LinkedIn, on X, and on Blue Sky particularly. And of course, subscribe to the channel and tell to your friends if you enjoy the content here. So what about REST endpoint? The first thing that we want to discuss is this concept of separation of the front end and back end. If you were here with me in the previous chapters of the book, we have discussed the fact that you can have your backend replying to your front end client, so the browser. The browser is the front end client. I'm gonna here refer only to browser when I talk about web application without separation of concern, and you will see why that's needed. So you have the browser sends HTTP requests to the backend, to the server responds back with something that it's HTML, CSS, maybe JavaScript or other languages, plus images, sounds, and so on. All of these are interpreted and displayed as interpreted by the browser. Fine. Now there is that's good, it's working fine, just that all the responsibility in this design remains of the backend side. So when you have a larger application, it becomes a little bit more difficult to handle things in only one place. So this is where the separation of the backend and the front end helps, because with a larger application, especially with an application that has a little bit more logic than just a few pages, now it's better to have a way in which you separate the way you display the things to the user and interact with the user from the business processes behind the scenes. And how do you do that? You separate the front end and the back end. You have front end applications handled with particular languages that have particular ecosystems and libraries and frameworks, such as JavaScript as a language plus its libraries and frameworks. And these are handled in the browser, but you have a lot of logic there compared to what you have had when you were using the approach where the backend does everything. Why do you have a lot of logic? Because this browser now is running an application. That application from the backend only receives raw information, eventually formatted in a nice way such that it's easy to parse, like JSON or XML or any other format. Okay, you will see 99.99% of the cases have JSON, but representational state transfer, which is REST, doesn't constrain to a given format, but usually we do use a format. That's what you have to keep in mind. So the backend job is now just to do all the processing, all the business logic, all the communication for storing the data, all the communication with the proxies and so on, and deliver back to the front end only raw data formatted in a nice way such that it's easy to parse. So the front end gets the raw data and does whatever it wants to do with it. It can display it raw, it can parse it and show it with nice colors, it can create nice graphics, it can create animations, it can do whatever it wants to do in whatever way with the data that it gets back. But it is now these applications running in the browser's responsibility on how it formats the data, how it displays the data, and also how it interacts with the users. All these responsibilities are now decoupled from the backend side. On the backend side, however, we do process the data, we do store it, we communicate with the proxies, and so on. So this separation of concern is possible only if you have some protocol to exchange or method to exchange the data between what we call the client application and the backend application. And what we use is this so-called representational state transfer, on short REST, which is basically it's not a protocol but kind of a framework you can use to transfer the data over HTTP. So how does this work with Spring? Well, there is a good reason why we have started with chapter 7 talking about Spring Boot and Spring MVC. And remember, we have first talked about how Spring Boot works, then about how Spring MVC works behind the scenes and what's configured by Spring Boot. And then we talked about how we implement web applications with Spring MVC, and we also talked about the web scopes. And all those are important to be known up front, because knowing how REST services work build over chapter 7, the information you've learned in chapter 7, 8, and 9. How? Well, if you will take a look here, you will observe that this is basically the same diagram we have followed in the previous chapters. So when we started discussing about Spring MVC, we talked on the same diagram. Here is the browser sends the request is intercepted by the servlet container, which translates from HTTP into Java objects. Then the dispatcher servlet consumes all the requests in case of Spring MVC and has the responsibility to manage the request further by finding what controller is associated to a given path and method, delegating calling that controller, and then we had putting everything that the controller returns. And when I say returns, I don't necessarily mean what the method returns, because that wouldn't be true, but let's put like what the controller what the controller results into onto a template, which is called a view. And then that processed view or resolved view, because that's why this is called a view resolver, was sent back as a HTTP response and then interpreted by the browser directly. How does this change with REST? This part here is completely removed. There is no view resolver anymore. So the difference is that instead of finding out a template to put the result of the controller on it and then send back the already formatted HTML, CSS, and so on to the browser, now everything that's back from the controller, it's actually translated from Java object into a formatted string and then returned to the client through the HTTP response. So there is something missing here, which I actually didn't add it here on this diagram because I wanted you to focus particularly on the fact that the view resolver disappears. There is still someone who translates from Java object instances to that formatted string, which usually is a JSON, a JavaScript object notation formatted string. Again, REST doesn't tell you have to translate it into JSON, so that's why Spring gives you the opportunity to plug in here any kind of translator. You can translate, you have objects that translate from Java objects to XML. You have objects that translate from Java objects to YAML. You have objects that translate to whatever format, and you can even create your own and plug it in. But by default, you will have JSON, which JSON's purpose is to translate from Java object instance to a JSON formatted string. So that's why by default, you will see a JSON coming out of a call in case of a REST endpoint. Okay, but on the design, how does this change? Remember, it's what you have learned in the Spring MVC in the previous 3 chapters. Just that instead of having a view resolver that puts everything on a template to format all that HTML, CSS, and so on and put it back complete to the browser such that the browser only has to interpret it and display, now there is no more template, there is no more HTML, CSS. It's only raw data formatted, a raw string formatted that goes back, and then it's here on this side, on the client side's responsibility to do whatever it wants to do with that data. So that's why, particularly in this case, you need an application here that knows how to consume that JSON string, parse it, and display it in different ways. So going back, this would be either a mobile application, any mobile application. Usually today we have Android or iOS applications. They consume the JSON formatted string and they use it to display the things you see in your application. Or in the browser itself is not able to display something nicely just with a JSON. So we need to use a JavaScript library or framework usually here to consume that JSON and then show something nicely like text tables, graphics, animations, and so on. So this is how it works. These are the clients. Now they get the REST, and then behind the scenes, you know, the backend can be an ugly dark forest that has multiple processes communicating with one another that persist data and so on. But now we have one responsibility for the backend, a different responsibility for the front end. And the first thing you need to understand is what the responsibilities, what's the front end responsibility, and what's the backend responsibility. And again, shortly, front end responsibility, whether it is a mobile app or a web page, is to interact with the user and nicely display the data to the user, while on the backend side to process the data in a secure way, persist it, secure it in general, and do that with the needed performance. Of course, the second thing you need to learn, and as a Spring developer, as a Spring expert, to put it like that, is how it looks like behind the scenes. Which are the components that are involved in this whole process? How is the request flowing? No, and which are the components and which are those responsibilities? Fortunately for you, if you have already learned how simple web applications work with Spring MVC, REST endpoints are almost the same thing, just that the view resolver disappears and the object the controller returns is formatted by a different component into a formatted string. And by default, if you don't plug anything on your own, here this responsibility will be taken by JSON, which handles this translation from instance to JSON. So now it should be pretty easy, especially if you have followed the previous 3 chapters attentively. Now let's take a look on how the code looks like in Spring. So listing 10.1 shows you what I had to do to instruct Spring that my application is no longer a normal web application that uses a template such as the time-live template, but a REST endpoint or an application that exposes a REST endpoint. It can be both, by the way, which is something that rarely is and I don't recommend, but it can be both. It can be both an application that uses time-live and it uses templates and also exposes REST endpoints. You can have that. But that's still something you usually do only with very small applications and just to have something like asynchronous calling, but otherwise you don't need something like that. But you will see that you can do that if you want. So going back, what makes this controller a REST controller? Well, particularly in this case and intentionally, I didn't make this controller a REST controller because I want you first to understand that in reality, the difference between the Spring MVC simple app, web app, and the REST applications happens at the method level and not at the class level. Why it happens at the method level? Take again a look on the diagram. The dispatcher servlet here at step 4 calls a method on the controller. It doesn't care that this controller class has one more or only REST defined actions. Okay? So in this case, what I want to enforce is that this hello controller class is the same kind of controller you have used in chapters 7 and 8 and 9 to create simple web applications. Just that I have annotated it with a different annotation that you have not seen up to this point, which is called response body here on line 5. So this response body makes that on this diagram, the dispatcher servlet now knows that what I want when I call that method in the controller is not to look for a view resolver. Is the way I tell the dispatcher servlet, don't look for a view resolver because it doesn't exist. Just take what the method returns, transform it into that formatted string, and then push it back through the HTTP response. So I see some questions already. Thank you very much, guys, for being here with me. Let's see, how can we guarantee that only our front-end application can communicate with the server? Excellent question. That is something we usually do with Spring Security, with authentication and authorization. So I will not touch it in this playlist, but you have already a playlist on Spring Security for that. So there are several ways in which you can do that, but they all of them are nothing else than authorization mechanisms that you usually implement in a Spring application with Spring Security. So is it a good idea to use TimeLeaf or go with decouple with React or any other front-end framework? A very good question again. So I would go, if I know I have a very small application, which is very rare today with Spring, but say I would have a very small application, something that I don't expect, where I don't expect to get more things into. It's just more like, I don't know, a tool or something that has just a few pages. Then it might be more comfortable to go with TimeLeaf. But in the majority of the situations where we use Java nowadays and Spring, I would say that in my experience, the majority are usually either large applications or applications that tend to become, or they have to be, they have this largest being on the plan. So in that case, I would directly go with the decoupled front and back end. I hope that helps. So let's go back again. On the code, you can see it clearly. So it is the response body annotation which makes the magic actually. Now what happens, see, I can have multiple endpoints, and I can even have, as I was telling you, I can even have endpoints that that return directly the body, making them REST endpoints, and I can have also endpoints that are then translated into a template. So I can have a mix of them. Like I could have this response body annotation here on line 11 removed, and in that case the endpoint chow would become, or would fall on the flow that we have discussed previously. So these two can exist together, okay? Because it's at the method level where this is applied, is the dispatcher servlet, it interprets method by method what happens. Some other questions, great. So can you get started with Spring Security after going through the Spring Start here? Definitely, I would actually recommend you do that. So once you have all this in place, you know all the basics you need to dive into Spring Security. And then I think I even at some point in this book I do refer to my other book, Spring Security in Action. You should be able to understand it. If there is something unclear, you know, you can find me on social media, but normally you should be able to understand Spring Security after learning the basics that are presented here in Spring Start here. How this flow goes once controller returns exception? Oh, very good question. We will talk about that as well. Be a little bit patient. We talk about exceptions as well. Yeah, I see some of you already replied, but yes, we will dig into that. So be patient with me because I'm going to take it easy, but we are going to talk about these situations as well. Cool. So I want you to understand first how things are implemented. I think we talked enough about that. But then you will see that in the real world out there, in general, developers don't use this response body annotation too much. It's very rarely that you see that. However, instead, when they implement REST endpoints, instead of annotating anything on the methods, they do use a different annotation on the class. So instead of controller, you very often see REST controller. What does REST controller mean? REST controller is a combination between controller and response body. So what does this do is making all the methods inside this class returning response body. And why do we use that more often than going with the response body? Because in general, when we use this approach, we have a backend frontend separation already, and it's unlikely that we will have situations where we do not use the response body annotation, which means that we would have to apply it over every method, and that would create boilerplate code. Is there a way to minimize the code, make your application less verbose by not repeating the response body, just supposing it exists? Yes. Instead of having to add the response body annotation over every method, just use REST controller instead of controller, and then you don't have to put them automatically. All the methods inside will go on the response body flow. Okay, and you can test it yourself. This is from the book. No, this is controller. Okay, we don't necessarily need to put it, but let me try to select something here. Anyway, and if I search for REST controller, okay, what I want you to see is actually that the REST controller is nothing than an aggregation of the controller and response body annotations. Okay, this is where it comes from. That's what REST controller. REST controller is not an independent annotation. It's a combination of the controller and response body annotations. Okay. Okay, going back. So how it works? Yeah, if I want to call this now, I would have to use a tool. You can use CURL in the command line. You can use Postman, Bruno, or any other similar tool if you want a graphical interface to create a call. But most importantly, you need to have the right method. You need to have the right URL here. So for example, in my case, if I'm running on the local machine, I will have localhost. I will probably have 8080 unless I have defined explicitly a different port, because 8080 is the default port as we have seen previously with Spring Boot applications on which Tomcat is configured, and then the right path here. And when you run this, then you will get your response here, which in my case it's a plain string, just because I have returned nothing else than a plain string. But if I would have had an object here, then I would have seen, instead of a string, the JSON, automatically the JSON formatted string of that object, which happens out of the box because JSON, which is by default configured in your Spring Boot, knows how to do that. Here there are some examples, on how to run them, even with more details with CURL from the command line if you want. And I think we can step over that because it's just how to call the endpoint yourself. I can show you how to do that if you want, but we don't necessarily need to go through all these details to save time. And talk directly about what happens if we have, again, an object, and how does that JSON work behind the scenes. So say you have an object like this class country, which has two attributes, a string and an int. I have this very small utilitary method to create a country, which I just created, and I return it. And then you can see that this endpoint runs, returns a country now, which is the instance with these particular values created with my method. In this case, this is how the response will look like. Why? Because JSON automatically transforms the object with the attributes into its JSON representation. In the JSON representation, we have the curly braces defining an object. We have attributes of the object separated by comma, and the attributes have between quotes the attribute name, a colon, and then followed by the value, which can be a string, like in case of France, an int or a double or a different primitive, or another object case in which you will see here some other curly braces and everything repeats over and over again. Okay, and this is how you see this into a GUI like Postman. See, I've called the endpoint, and then I get back the body, which is a JSON formatted. Above the JSON formatted response, you also see the 200 OK status here. This is an essential information. Whenever we deal with a body of a HTTP response, very important is you have the body, but in the HTTP response you also have a code, which is a short information indicating through an int what's the status of that of the request. Has the request worked properly? Were there problems, and where were the problems? The problems were at the client side or at the backend side, or maybe it was a redirect. No. And we also have headers. You cannot see them here. Now you have headers in the request, but you also have headers in the response, which we can use to return data. So there are three main ways, in three main places where you can put information in a response. Okay, and this is then a following example, and I'm building over it here. I complicate a little bit the things by showing you how to return a list or a collection in general, just to show you that you can also return a collection. And then you can see here, in case of a collection, we have the braces, and this is a collection of objects, so it's braces, and then the objects are separated with comma, and they look the same way in which you have expected. So question, can you explain us how servlet HTTP session actually works? So yes, it has about the servlet, but it's in chapter 7 and chapter 8, and we have discussed them already, because now we are talking about chapter 10. So you can go back to one of these episodes. I'm not sure we talk about HTTP session too much. We talk about it a little bit here in the scopes, here the session scope. So here we talk about the session scope, and that's where we discuss about the sessions. And here we talk about how the servlet works at the very beginning. So we have started with, first of all, how it works, and we went then into REST. This is already basically the 4th chapter where we discussed web applications. So my recommendation is we can go to chapters. If you haven't already, most likely you haven't, no, because otherwise you have seen them. You go back to chapters 7, 8, and 9 and get that details from there. Okay. And so, okay. Here talking about the statuses, no, very important. I was giving you this a little bit in advance. What do we need to know is that this status is very important. This is as important as data, as any other data on the response, because in a big majority of the cases, the clients first of all look at this code to understand what happened, and even we as developers, we are interested in this code, and we look first at this code to understand. You will see that in general, a developer is happy when it gets a 200 family. We call it 200 family, means 200, 201, 202, 203, and so on. All of this means everything went fine. It's just a little bit slightly different, but it went fine. So 200 is just the generic one, and then 201, I think it means accepted or created. I don't remember exactly which is which. 202 is created, 203 is something. Anyway, all of them mean it went good. It was okay. So that's usually when you see displayed with the green everywhere, and everybody's happy. And they are happy, and everyone is happy unless you have improperly use them. Never ever return a 200 family when there is a problem. Someone was asking me earlier about exceptions. We will talk very soon about them. When you have exceptions, you should never return a 200 OK, because an exception means something went wrong, and that something could have been wrong with the data you get from the client, or it could have been wrong with the data, how it was processed on the server. But in a way or another, it should be something else than a 200. The 4 family, 4XX, so 400, 404, and so on, they all mean there was a problem with how the client created the request. For example, 400, like 200 is the generic OK, 400 is the generic bad request. We don't say what was wrong, but it was a bad request. 404 means the path wasn't found. So maybe either the method or the URL is not correct. Usually the URL. It can be the method as well. 401 means unauthorized. 403 means forbidden. Usually unauthorized means something was wrong with the authentication. Forbidden means something was wrong with the authorization. I know the names are confusing, but that's how it works, is because of the fact they were created a long time ago. And so on. 4 something means something is bad with the request created by the client. While 5 something, like 500, which is the generic one, something was wrong on the server side. And this is what you should return when something is wrong, like when you have an exception. Good. I see APIs which return 200 and error field containing the error. Bad design. That is a bad design. You should never ever do that. Okay? So whenever you see such an API, it's just nothing else than a bad design. The statuses are there for a reason. When we do not respect them, it means we are creating anti-patterns, and in the future this will bring problems usually in the maintainability of the system. And then is JSON instantiated as collaborator bean in the dispatcher servlet, or is it somewhere in between the dispatcher servlet and the controller? So as far as I know, it is a dependency called by the dispatcher servlet. So it's when is the diagram here? When the dispatcher servlet calls the controller, gets back the response, then it looks for someone who is able to translate the response, and it loads that someone and calls the method. In this case is the method of the object mapper object, and then returns the formatting. So it's decoupled. In other ways saying, it's has a dependency rather than, I don't know, something else. And that's what also gives us the possibility to provide some other object, because you can configure it by default. You have JSON, but you can use something else, and you can make easily your Spring Boot application return XML formatted. Okay, someone says I handle all exceptions. I throw for something and the generic exception with 500. Is that good design? I thought I should give exception messages for exceptions not thrown by me. I should give so point is like that. When you handle exceptions, if it's a client problem, it should be a for something. Now it is the decision of the developer which for something will be, but usually the message should be fulfilling with the description in the specification. So it is kind of strange to have a 403, which means forbidden, when in reality it was a wrong URL. You shouldn't do that. So it always should match to as much as possible to what the description in the specification of the HTTP for that status code. The same with 500, but 500 something, it's always on the backend side. Now regarding the body, that's a very important question. Sometimes it is good to provide some details, like for example, when you have an invalid parameter that will be a 400 or a 40 something, and you tell the client parameter X doesn't have the right format, or it doesn't have one of the proper values, or so on and so forth. Be descriptive in this case with the client in the body. And usually when you do that, also format even the exception as a JSON, so it's easy to parse. But when the problem happens on the backend side, that's where usually it's not recommended to have a descriptive message. So remember, if you have an exception on the backend side, never put that exception stack trace into the HTTP response body, so back to the client, because it might be that the exception stack trace, reveals internals of the application like package names, class names, and sometimes even versions. It might say which is the version of Tomcat you are using. Some bad intentioned person would be able to use that to see if that version has any vulnerability and then try to hack you in. Okay, so generally these are the rules with messages and exceptions. And then of course I was telling you we are discussing exceptions, and you see exceptions at the endpoint level now. So what happens if you have an exception? Of course it depends on the type of exception, no, but let's be generic. So say that some exception happened, which is a business flow exception, like this not enough money exception. We can exercise a bit our imagination and think that this is a payment call, and then at some point we discovered that there are not enough money in the account, so we throw an exception for that. We don't have to debate too much on why this is designed for the business. We just think that this is the case. And then how do you handle that? Well, there are two ways to handle that. First way is to handle that directly at the controller level. This is usually, at least from my point of view, not recommended. It's usually easier for the beginners because they see the code exactly where it is, and it makes things easier to understand. So you call the method, you cache the exception, and then you return a response with a body based on that. Okay, which normally this one should actually be now 400. I'm not sure exactly what I did here, but normally this should transform in a 400. So this response entity bad request, okay, it's a 400, it's good. With a message, a proper message telling the client why this is wrong. Hey, you, the client, you don't have enough money. Okay, this is okay. And the other way to do that is to have an exception controller advice, a REST controller advice. So another question, is it recommended to return response and to avoid from a delete request, or should return returns? It doesn't really make much of a difference, to be honest. If you, in terms of code, write void class there as a generic, or the question mark in this case. Remember that that generics in Java, they are just a flavor that it exists only up to the compilation. The generics at the moment now in the latest Java version, they cease to exist after the compilation. So as long as you can return what you do, whether you put void or question mark there, it will not make too much of a difference. Important is to be compatible with the instance you want to return. Of course, you cannot return something that is different than the type you specify with the correct wildcard. So as long as it works for you, in this case, there is no good or bad recommendation. It's just a generic. So remember, it's just a constraint you have, which will cease to exist after the compilation. Going back to the control advice. So what does this do? It basically clears a lot of the controller. See, that's why I don't usually prefer using try catches and handling of the exceptions at the controller level directly, because usually it messes up a lot. It creates big controller methods with a lot of boilerplate code, and which potentially also lead to code duplication. So instead, what is the solution? Decoupling in an advice. Remember, we discussed aspects in chapter 6. So what is a REST controller advice, which in our case will become an exception control advice because we use it for treating exceptions? It's just an aspect that helps us decouple the logic for treating exceptions. So your controller will just remain empty with the happy case, and if this method throws an exception, then this is something you will handle somewhere else in a different class by making it this way a lot easier. So you go, first of all, the class will be smaller, the method will be smaller because it only has one responsibility now, easier to understand, easier to see, and you go there only when you really need to go there. So this way it allows you to focus on the business logic easily at the controller level, and it allows you to focus on the exception logic at the REST controller advice level. Why the name ends with advice? What it conveys? Oh man, I have no idea why they call this. I mean, to be honest, normally, so you know what an advice is. If you want, we can go back. So the advice is when we say when will that be called. Okay, so we have the point cut, which represents the wrapping, the aspect, which is the logic, the advice that tells when it will be cut. Now, why did they call it REST controller advice? Probably it makes sense now, because it's something that you know. It tells you when. No, it tells you when will this be called, when an exception happens. So probably that's the case. No. So remember that aspects. Now I'm going very quickly to chapter 6 to remind you what the parts are. I had a diagram here, if I correctly remember. Okay. Oh no, this is something maybe up there. 1 second. Oh, this is it. No. So the advice is the when. Okay. You see the sentence. So we want some logic to be executed before each execution. So the advice is the moment, the precise moment reported to the event for when this happens. So probably it makes sense to be named REST control advice, no, because it's something that we implement at a given moment, which in our case is the exception. I think this is the explanation, no, for this. So should I create a custom exception for all my uses? I currently use one exception class per domain object. Honestly, yes. I mean, it's the recommended is you segregate the exceptions. This is something unrelated to our talks, so if you want to take it in more detail, let's take it separately. But the short answer is yes. Normally, it's recommended to avoid having one and only one exception for all the cases. This is basically the mistake that was the design mistake that was made by the JDK when creating the SQL exception. SQL exception has precisely this flow of design, because SQL exception might mean the syntax, the SQL syntax is wrong. It might mean the connection didn't work. It might mean the authentication didn't work. So see, it has too many responsibilities. So shortly, yes, best practice, you have independent segregated exceptions. Okay, and the last thing, and then I'm gonna close it. So you saw how this is implemented. Okay, it's decoupled, and we decoupled it into a separate class, and we discussed about the advantages. No, the advantages and why I consider it recommended to do it like that. And then what is the last one? So using a request body to get the data. I was pretty short again. When I will write the second edition, I will extend this because I just touched the technicalities and only the minimum technicalities. This was also part of the philosophy of the book. It was try to put there only the things that start you up. No, that's why it's called Spring Start here. But I would like to put a little bit more. However, this only shows you how to map a request body with the request body annotation. Pretty simple stuff. The other thing that I would like to discuss at some point is which are some best practices on naming these endpoints, and I plan to create a separate video for that. Okay, to not mix it with this playlist that focuses precisely on the book, but I will separate another discussion where we talk a little bit also on the best practices on how you use REST and not only on the technicalities. And this is basically it. So this is the chapter showing you quickly the minimum you need to know to implement REST endpoints, and then from here, of course, you can extend it and discuss about parameters, request parameters, query parameters, path variables, response body, and so on and so forth. So there is a lot more to talk about. I don't want you to believe that this is everything. Hey, we talked about 20 pages here on this in Spring Start here, and then suddenly this is everything we can use. So it's a little bit more than that, but remember that Spring Start here is a book that starts you up. It's not a book that it's meant to give you all the possible details on even creating REST endpoints. So this is the minimum. Okay. Add also a chapter about application events in Spring and maybe best practices. Not really sure what application events are. You refer to reactive applications or something else. I would not mix, to be honest. It's reactive programming. It's a little bit actually a lot over the basics. So I don't see how a chapter about that would fit into Spring Start here. Maybe if you refer to events like send to RabbitMQ or Kafka would make a little bit more sense, although those are also a bit beyond, but we can figure out it's a different communication style, and today we use a lot of them, so I will think about that. I will consider it. But let's get there. Let me get to the point where I start a second edition, and then we can debate it. I will announce it on social media, and you will be able to debate it on whatever you want to be in there. And I will of course try to put as much as possible from your requests. Cool. With that being said, I'm ending it up. Let's wrap it up and meet next time to talk about the next chapter, which is about consuming REST endpoints. With that being said, thank you very much, everyone. Have an excellent time for study further. I'm waving goodbye and talk to you next time. Cheers.